Do you guys remember what were we doing yesterday? Do you guys remember what were we doing yesterday?
We were looking at the
Theorem for congruence. And that is where we looked at two of the theorems. One was SSS, second one was SAS. Yeah? And then what we did not do was ASA and RHS. So again, for some of you who missed that yesterday, or some of you who are not able to recall, when we talk about congruence of shapes, we essentially mean the shapes being exactly the same, meaning they having the same properties. And when we talk about properties, we know what properties are. When we talk about a triangle's property, we know that it has 3 sides and 3 angles underneath, right? And when we talk about rectangle or a quadrilateral, we talk about 4 sides and the 4 angles. Those are the properties. So when we say two triangles are congruent, what we mean is they have matching properties, meaning one side in a triangle has a matching side in another one. Second side in the first triangle has a matching side in the second triangle. Third side in the triangle has a matching side in the second triangle also. Likewise, the angles also matching. So that's what it is. So once you prove that the two triangles are congruent, you can safely assume that each and every property are matching. Okay? So we looked at theorem SSS, meaning when the 3 sides of the two triangles are same. When the 3 sides of the two triangles are the same. This triangle and this triangle. This side is same as this one. This side is same as this one, and this side is same as this one. They are congruent. And when they are congruent, that means angles will also match. Angles will also match. Angles will also match. Okay? So that was SSS. When we look, and we also saw how to prove that also, right? When I asked you guys, can you draw two triangles with length 5, 8 and 9? And you guys came back to me apologizing, saying, sorry sir, we cannot do that. Not because we don't know how to draw a triangle, but because there is no way I can draw it. Yeah? Then we looked at the second theorem called SAS, side angle side. Meaning, if there are two triangles, this and this, where one side is matching with this side, second side is matching with this side, and the angle between them is matching, then the two triangles are congruent. Because we saw that if the sides are of same length and the angles are same, this length will be the same. Because for the same length side, if the angle changes, then this side changes. Since here the angles are same, so this side will be same as this one. So these two triangles are also congruent. Everybody remembers that, or you forgot? Everybody remembers? Okay, very nice. And if you forgot, that's okay. I want you guys to keep on forgetting things so that I can keep on teaching the same thing again and again. Okay? No, I'm just kidding. So if you forget, it's okay. I mean, forgetting is perfectly fine. Just that don't hide. Don't keep it to yourself. Don't assume that, yeah, no, I did not forget. And when you end up solving a problem and you get stuck, that'll be bad. It's okay to say, I think I remember that. Let me try recalling it. If you fail to recall, ask me one more time. It's okay. Whatever we learn, we can learn multiple times also. Okay? Now, we are coming to the third theorem, which says ASA, meaning if I have two triangles like this, where this angle is same as this angle is same as this angle, and the side between them are also matching, these two triangles will be congruent. Now, let's try proving that. I see that there are two triangles where these two angles are matching. Okay? And this is the length of the side. Now, we are trying to say that okay, these two triangles are congruent. How? Now, first of all, look at this. These two triangles have matching angles. What does it mean? the third angle will also match. Yeah? Third angle will also match. Yeah? That means these two triangles have matching angles. So they are similar triangles, aren't they? Yeah? If the two triangles are similar, what do we know from the property? If the two triangles are similar, that means their sides will be in the same proportion. What it means? This side is opposite to this angle, right? So let's say we call it ABC and DEF. BC and EF are same. Let's say BC by EF. BC by EF. These two are same, okay? So I'm saying this angle and this angle are same. So the opposite side, BC by EF. Now this angle and this angle are same. So side opposite to this, AC by DF. Okay? AC by DF. So, okay, I am not trying to confuse you guys. Let's try recalling two concepts. First concept that we had learned before, that if there are two triangles which are similar, then their sides will be in the same proportion. So here we saw that in these two triangles, this angle and this angle are matching, this angle and this angle are matching. That means third angle will also match. Yeah? And we also know that this side is equal to this side. That is given to us. Because this is ASA. Angle, side, angle. Angle, side, angle. Okay? So two angles matching, third angle has to match. No other choice. Because sum of all the angles equals to 180 degree. Yeah? So here, these angles are matching, meaning they are similar triangles. If the triangles are similar, meaning the sides will be in the same proportion. Meaning this side, so this angle and this angle are matching. So side opposite to this one is BC by the matching angle for this one is this one. So side opposite to that is this one. So BC by EF will be equal to, pick any one. Let's say EAC. AC is opposite to this angle and this angle and this angle are same. So side opposite to this is AC divided by side opposite to this is DF. Now, if BC and EF are same, then what? AC and DF will also be same? No? Because if this is same, so I can say BC is equal to EF. Let's say BC and EF also I'm writing as BC only because they are same. Right? If this is 10 centimeters, this is 10 centimeters. So I can say 10 and 10 here, right? So this equals to AC by DF. And BC by DC, tic-tac-toe, it becomes 1. So I will say AC by DF equal to 1. Or AC equal to, it goes here this way, when I am making it cross the border. So it becomes 1 into DF. That means AC equal to DF. AC equal to DF. Now what happened? We knew that, what we found out is that this side is equal to this side. This side is equal to this side, that is already known to us. Now we found out that this side is also same as this side, meaning these two sides are same. And the angle between them is anyway same. So we can again go back to SAS. Side, angle, side, same. So this one is also true. Now let's go back. Again, I know I shared a lot of information. Let's go step by step. How did we prove this? So that you can relate. What we are trying to prove is ASA, meaning I have two angles matching and the side between them is matching, between the two triangles. Okay? And I am trying to find out if they are congruent or not. Yeah? So when this triangle and this triangle, what did we do? We know that this angle, let's say this is 1. If this is 1, this is also 1. These two are matching. If this is angle 2, this is also 2. This is also matching. Okay? If 1 and 2 are matching, 3 and 3 will be matching. Okay? You guys are not going to argue with me on this one. Ever. Because you know that the sum of 3 angles is 180 degree. When 2 angles have already matched, what is there to argue? Yep. Yep. Everybody? So that means both the triangles have matching angles. And we are also told this side is same as this side already. Yeah? Now since these two triangles have matching angles, that means they are similar. And when they are similar, that means the side opposite to this one, let's say it's A, B, C, D, E, F. So then their sides will be the same proportion, meaning side opposite to 1 in both the case. What is that? AC, side opposite to 1 is this, AC. AC divided by side opposite to 1, this is 1 here. Side opposite to that is what? DF. AC by DF is the same proportion as the second one. Now this side is opposite to 3. So BC. 3 is here. Opposite to this is EF. Okay. Now we are already knowing that this side and this side are already same. That is given to us. Yeah. That means BC by EF will be equal to 1. That means AC by DF will be equal to 1. That means AC will be equal to 1 into DF. You know how to make the how to make the things cross the boundary, right? Yeah. So if it here on the equal, if the division here behind is equal to sign, if I make it travel that side, from division it will become multiplication. So AC will be equal to 1 into DF or DF. What it means? AC will be equal to DF. So earlier we knew that one side and one side are matching. Now we found out that second side is also matching. Now two sides are matching and the angle between them is anyways matching. So we can same go back to the old theorem that we have proved in the past. And say this is also congruent. Meaning if there are two triangles with two angles and the side between them are matching, they are congruent. Yeah? Everybody with me? Or I am creating confusion? No? Amoga, Sagarika, Diksha, Dikshita, Vivan, Rashika, Myra, Cherry, Janvi, anybody? Pranav? No confusion? Okay. So that means we learn how to prove the third theorem also. See, these theorems are like proven fact. But like I always say, math is the subject where you don't have to trust anybody, not even your teacher. You have to do it yourself. So that is why you are forcing your teacher to prove. I could have just walked away by saying that these are the 4 theorems for congruence. Like it or not, memorize it. You guys did not allow me to walk away by making that statement. That's why I am forced to prove it. Yeah? So, but on a serious note, when we are proving it, now SSS, ASA, SAS, all the 3 theorems we have proved by ourselves. Meaning, we don't have to trust anybody. We have seen it ourselves, so we will not forget it. And we can apply that when we do sums. Okay? When I give you guys assignment, you'll be able to apply that while doing the sums. Okay? So far, any questions before I move on? Alright. Shall we move to the next one? Everybody? Okay. And I expect each one of you to be as vocal, as clear, as communicative as possible, okay? Don't think that if others have understood, I have also understood. No, that is not the case. What you will write in the exam is what you have understood yourself. Okay, so don't rely on your friends. Okay, if my friends are saying they have all understood, I don't have the option of saying no. I want to understand one more time. It is only for you. If you have not understood, ask it with confidence. Okay. Yeah. All right. Okay. So now let's go to the fourth theorem. That is called RHS. So here, this theorem is only for right angle triangle. R stands for right angle triangle here. So that's why the other three theorems that we saw, that applies for each and every type of triangle. But this theorem is specifically for right angle triangle. And trust me, right angle triangle is such a spoiled triangle. Right angle triangle is such a, when I say spoiled triangle, meaning it is such a pampered triangle, okay? The whole subject, trigonometry, revolves around this right angle triangle, okay? So that's why this guy has extra privilege. This guy is pampered. This guy is given extra value that you'll get to see, okay? Whole concept of trigonometry and calculus revolves around this right angle triangle, okay? So that is why there is one theorem dedicated only to right angle triangle, okay? Now let's look at it. Do you guys know what is the hypotenuse in a right angle triangle? Say it. Say it, say it, say it. Somebody has to say it. Louder. Largest side of the right angle triangle. Yes. Okay. So if this is my right angle triangle, what I'm saying is, one of the angle is 90 degree. Yeah. That is why it is called right angle triangle, because there is a right angle in the triangle. Yeah. Now, which one is hypotenuse? The angle that is opposite to the 90 degree. Sorry, the side that is opposite to the 90 degree angle or the right angle. The hypotenuse, which is the largest side of the triangle, is the side opposite to the 90 degree. Yeah? Everybody with me? So, this is called hypotenuse. Okay? Now, what this theorem says is, in a right angle triangle, if hypotenuse and one of the side matches, meaning if I have two right angle triangles where the hypotenuse, this one and one of the side, any one side. So after you have taken the hypotenuse out, what you are left with, this side and this side, or this side and this side, says if hypotenuse is matching and one of the side is matching, meaning this side and this side, these two sides are matching, or this side and this side are matching, then they are congruent. So if I repeat this theorem, what it says is, in case of a right angle triangle, if you have the hypotenuse of the same size and any one of the sides matches, then your triangles are congruent. Do you think this theorem is correct? Do you think this theorem is correct?
Yes.
Why you think so? I'll make you think. And it's okay. See, again, I'm not trying to put anybody on the spot. I'm trying to see how do you align your thoughts. How do you put your thought process to solve a problem? I gave you a problem without even explaining it. I said, there is a theorem which says, in a right angle triangle, if the hypotenuse match and one of the side matches, they will be congruent. Yes, Sanvi. Let's see what Sanvi says.
Since one of the
Uh-huh.
two of the sides match, then the third side also has to match.
Why?
So then the angles will.
Why will the third side match? You have to be more specific. No, I know you know it. I'm just making you say it, okay? Think about it. Somebody was raising hand. Who is it? And you guys will laugh at it when I disclose that, okay? Anybody was raising hand? No? Okay. One more time. See, this is going back to my old boring concept that I tell you guys always. And that is called tran. Trust yourself that if anybody can solve it, I can solve it. I know many of you have heard it at least 10 times. R stands for read, read, read and read. When you read the question multiple times, the question becomes easier. Then you analyze how will you solve the problem. You make your mind how you are going to solve it. What are the information you have got by reading it multiple times, by recollecting the formulas that you know. And then comes N, which stands for Nike, just do it. So once you have read the question enough, if you trust yourself, you have read the question enough, then you have analyzed how you are going to solve it, then you use Nike for doing it. I am not a brand ambassador of Nike, I don't have Nike shoe either. But I like the slogan. Now, coming back to what I was saying, read, read and read again. Let me read the question one more time for you guys. In the scenario of a right angle triangle, if the hypotenuse and one of the sides match, the triangles will be congruent. And as Sanvi said, the third side will also match. And that is right statement. That is a very accurate statement. What Sanvi missed was, she forgot to give me the reference of Pythagorean theorem. The Pythagorean theorem says, a square plus b square equal to c square. Square of one side plus square of second side will be equal to square of hypotenuse. If hypotenuse are matching, up now let's say this is A, this is B, this is A, this is B, C. C is matching. Let's say this is not A. Okay. Let's say this is A, and I don't know whether this is B or not. I say this is B. So A are matching. Hypotenuse are matching. So A square plus B square equal to C square. A square plus B square equal to C square. In the first equation. Okay. Now in the second triangle, here A we know is matching. So A square, since this is also a right angle triangle, so A square plus B square, I am saying this is B, equal to C square. This is anyways matching, equal to C square. C in these two equations, C square is common, A square is common. Why would B and D not be the same? Yeah? Do you guys agree? Yeah. So that is how, if you are looking at a right angle triangle, if the hypotenuse and one of the side matches, third side has to match. I can even make it more generic for you guys. That theorem doesn't exist, but I can tell you that in any right angle, if there are two right angle triangles, any two sides match, be it hypotenuse or not a hypotenuse. If any two sides match, it will be congruent. So even if this side and this side match, that will be congruent, because this square plus this square equals to this square. If these two sides are matching, hypotenuse has to match. So even if the theorem says that if there are two right angle triangles where the hypotenuse and one of the side match, then they will be congruent. I'm giving you a different theorem altogether. I'm telling you that in a right angle triangle, if any two sides match, they'll be congruent. Do you guys agree? Yeah? Because Pythagorean theorem says so. Alright. And we have already proved Pythagorean theorem. See, the thing here is, whatever we have proved before, we don't have to keep on proving it again and again. So when we prove this one, we can always give a reference of this one when we are trying to prove this. Okay? So that's what we did, right? We knew that, okay, if I can prove two sides and the angle between them is same, they are congruent, we used the same thing. Here in this case we had one side matching, we found out second side matching and the angle between them and gave a reference of this guy saying, okay, these are congruent now. Everybody with me so far? Let me ask one by one. So Sanvi, no question? Okay. Pranav, no questions? Very clear? Okay. Amoga, no questions? Okay. Deekshita, no questions? Myra, no questions? Okay. Then Sagarika, no questions? Then Gaushika, no. Then Vivan, no. Then who else? I'm not able to see you on the screen. Then Pranav will talk. And then Sanvi will talk. Siddharth, any questions? Oh, Vivan, sit properly with us. Siddharth, any questions?
No.
No? Okay. Okay. All right. So, see, that's what I'll keep on asking you guys. So, these are the theorems that we need to know, that we have learned. So, we learned all the four theorems for proving the congruence of triangles. Meaning, SSS, when the three sides of two triangles match, they are congruent. Meaning, after that, every property will match. When we talk about SAS, we are talking about two sides and the angle between them matching. If there are two triangles where that is the case, they will be congruent. ASA is a theorem which says when there are two triangles, when the two angles match and the side between them. Remember, these are two angles and the side between them. Be careful with that. If somebody says these two angles are matching and this side is matching, it might be correct. It will be correct, but that is not what the theorem says. So you will always look for the two angles and the side between them. Okay? If it says, okay, now let me give you guys a different flavor. Third theorem was ASA, fourth theorem was RHS. Now, I am not writing my own book, but I am giving you guys different theorem, okay? And those are relatable, okay? It's not that I'm kind of inventing something new, but we are relating it. Now, let's look at the theorem ASA. What this says, if there are two angles in the triangle match and the side between them match, then they will be congruent. I can give a different flavor of that theorem and say, if in two triangles, two of the angles match and any side matches, they will be congruent. And do you guys know why? Ideally, the theorem says mathematically that two angles and the side between them have to match. I am saying that this also is correct. Any two angle and any of the side matches, it will be fine. They will be congruent. Why? Because if two angles are matching, the third angle has to match by default. Yeah? And if the three angles are matching, be it any side, there will be a side between two angles which are matching anyways. Yeah? So if I said that these two angles are matching and this side is matching, as per this theorem this is not correct. But what I am saying is this is also correct, because your third angle will anyways match. And when the third angle matches, this side is between two matching angles anyways. Yeah? Does it ring the bell? Yeah? I am saying the theorem says any two angle and the side between them. I am saying doesn't matter. Any two angle and any side, if they match, we are good. Because if two angles are matching, third angle has to match. So you have three matching angles, and regardless of which side is matching, that will be falling between two matching angles any which way. So this theorem holds true. Yeah? Now look at my second theory that we already talked about. In case of RHS also, RHS says that if I have two right angle triangle and the hypotenuse match and one of the side matches, then they will be congruent. What did I say? I don't really care whether the hypotenuse matches or not. I am just saying any two sides in two right angle triangles match, they will be congruent. Any two sides. Because if any two sides match, if let's say this side and this side match, this side and this side match, third side will anyways match, because that is what Pythagorean theorem says. Yeah? So official theorem is ASA. I am saying AAS or SAA are also correct. Okay? Official theorem for right angle triangle says RHS. I am saying it is RSS. Not the RSS that you see in India. It is for any right angle triangle, any two sides if they match, they will be congruent by using the Pythagorean theorem. Are you guys with me so far? Yeah? Everybody clear?
Yes.
Okay. So now let's do some fun. No dancing, singing, but we'll do tables. So we have not done tables for some time, and tables are one of the most important part of maths. If we are thorough with tables, for you guys, right, since you guys are in level 2, I would want you guys to be very thorough with tables up to 15 by the end of this calendar year. Meaning by the time we finish 2024, I would want you guys to be champion in table up to 15. Meaning if somebody says 13 5s, that should be 65 without even thinking or blinking. Okay? So let's see how much we know, and I will keep on reminding you guys that you have to spend 2 minutes every day whenever you have an unproductive time window, when you are not doing something meaningful. Just think and practice tables for yourself. Okay? And that 2 minutes is very easy. Let's say I keep forgetting the table of 13 or table of 14. What will I do? I have 2 minutes. 14 1s are 14, 14 2s are 28, 14 3s are 40, 42, 14 4s are 56, 14 5s are 70, 14 6s are 84, 14 7s are 98, 14 8s are 112, 14 9s are 126, 14 10s are 140. And if I'm getting stuck, let's say 14 8s are, I don't know. Okay, so let me start from beginning, and 14 8s are 14 8s are 112, right? So 14 is a 112, 14 is a 112, 14 is a 112. 3-4 times I will practice, and then I will revise the table. So this whole exercise takes 1 to 2 minutes maximum, depending on the speed at which you can talk. Like my tongue gets stuck when I speak very fast, so I might take 10 seconds more. You guys might have a better tongue than me, you might be faster. But yeah, make sure that you guys are practicing tables. So let's see who knows how much of tables and what we need to do for making it more perfect. Okay. And it's like a challenge, right? So let's do this way. I am giving you guys a challenge that any of you just raise your hand and ask me any question on table up to 15 and see how I'm responding to it. That is what I'm expecting you guys to do. So let's do this exercise first. Who wants to ask me questions? Okay, Mayra, go ahead.
14 times
14 times 4, 56.
4.
Say that again.
52.
Did you say 13 times 4 or you said 14 times 4?
50.
So you have to be louder, okay? I heard 14 times 4. Okay. Go ahead. Mayra can ask 3 questions, then Dikshita can ask 3 questions. Dikshita, go ahead. Unmute yourself, ask me questions.
59.
59 is 135.
45.
Say that again.
14
14,
5.
70.
39.
39, 117. Okay, let's see if Amoga can make me fail. Amoga, go ahead. Unmute yourself. 13 7. 13 times 7 is 91. Go ahead. Quick fire. Okay, Siddharth. One question for Siddharth, one for Goshika, and then I'll start asking questions. Okay, Siddharth, go ahead.
15 times 5.
15 times 5, 35. Goshika.
15 times 7.
15 times 7, 105. Okay. So yeah, see, I was not trying to show off. I was just telling you guys that this is how I want it to be. Okay. And if I'm taking more time, that means I also need to practice. So that let's see who all is how thorough with the tables, and then I'll give feedback for next steps. So we want to come closer to the camera, but you're way too far. Okay. Alright, so let's start with Dikshita. Dikshita, table till 12 is okay? Okay? 12 7 jar.
84.
9 8 jar.
72.
8 9 jar.
6.
That was a trick question. 8 9 jar and 9 8 jar will be the same, 72. Okay? 12 6 jar.
72.
9 9 jar.
81.
Okay? So see, I know that you know the tables, okay? Just spend 2 minutes daily for next, I would say 2-3 weeks. Let's see that makes it more accurate, more fast. Okay? Alright, good job, Beta. So this is for Dikshita. So Dikshita has not disappointed me. She's doing good. Let's go to Sanvi. Sanvi, ready? 12 6 jar.
72.
11 8 jar.
88.
9 9 jar.
80.
Okay? 8 7 jar.
56.
Very nice. So good job, Sanvi. So these are like quick checks. These are like the playful way of learning something, right? If you know the tables, right? I mean, let's say if I know tables till, I keep on proving my point in between, right? So that's what I do. So let's say I have to multiply 785 by 16. Okay? what I'll do, I'll multiply 6 by this, then multiply 1 by this. If I know table to 16, what will I do? 16 5 is 80, 8 carry forward. 16 8 is 128 plus 8, 136, 6, 13 carry forward. 16 7 is 112, 112 plus 13, 125. So this helps you do your calculation faster, because these are the trivial things. You would not want to spend a lot of time on that one, right? I'm not saying that doing it step by step is wrong, but if you know the tables, that helps you do things a little faster at times. And that is what we will have to keep on trying, because once you go for SAT exam, right, you will have limited time. And you will have to find out different ways to save time wherever you can, so that you can save some time for the harder questions, which needs a little more time, right? So that's why tables are important. Okay, let's go to the next child here. Vivan, ready? 4 9
36.
12 6
72.
12 9
108.
11 7
77.
6 6
36.
9 9
81.
Good job. Same thing. Regardless of how thorough you are, make sure you are spending 2 minutes for yourself of your unproductive time. Everybody, okay? 2 minutes. See, once you get bored, don't practice. Any day, okay, fine. Catch hold of somebody in the family, okay. Catch hold of mommy, anybody in the family, okay. Sit, ask me questions on table till 12. Let's see if I remember them all. Right? When you give them that chance, they will ask some questions. And how quickly you are able to respond, that will give you that view of, okay, are you really thorough? They will feel nice about it. And you are doing that in a playful way. You're not actually studying. Right? So do math in the way you can enjoy, okay? Let's go to Pranav. Pranav, ready? Pranav, ready? Your screen is frozen. Okay. Let's go to Myra then. Myra, ready? Oh, Pranav, yeah, I can hear now. Go ahead. Are you ready? Pranav, you might want to drop off and join back again. Let's go to Myra. Myra, ready? Table till 12. 11 8 12 5 9 9 8 9 7 7 12 9 Good job. Okay. Now let's go to Siddharth. Siddharth, ready?
Yeah.
8 9
8 9, sir?
Yes.
72.
12 4
24.
48.
Oh.
9 9
81.
7 7
49.
8 8
64.
11 7
77.
Good job. So again, I'll keep on repeating myself. That might sound boring. Still, everybody has to spend 2 minutes every day, okay? Those 2 minutes could be for practicing the tables or for giving the challenge to somebody in the family. Say, okay, ask me questions. Okay? Alright, let's go to Rashika. Rashika, ready? 12 8
96.
11 9
99.
12 7
84.
8 8
64.
12 9
108.
Okay? So, good job. But same thing, I'll keep on repeating myself. Alright, let's see who did not. Sagrika, you are not. You are ready?
Here.
Okay. 12 5
But
12 5
60.
12 9 ja.
108.
8 8 ja.
64.
9 9 ja.
81.
7 6 ja.
42.
4 9 ja.
36.
8 9 ja.
22.
Very nice. Keep practicing. Practice makes everybody perfect. I would not say practice makes only a man perfect, okay? Because practice is something important for everybody. Alright. Who has not done it yet? Pranav is done. Okay, Amoga, are you ready? Okay. 12 9 ja. 8 9 ja. 12 6 ja. 7 9 ja. 9 9 ja. 12 8 ja. Have you done table beyond 12 also? I'm sorry? Okay. So right now, let's say till the month of July, we'll focus on table till 12. August and September we'll focus on 13 and 14. Okay? So whoever picks up early, better. By the end of this year, I want to make sure that everybody in the class is champion in table till 15. Because that will help you expedite your calculation speed. You'll be able to solve things very much faster actually. Okay? So that's the purpose why in one of the class I spent 10, 15, 20 minutes to make sure that we get the chance to dress up the tables so that keeps enabling our calculation speed. Okay? Alright, so what are the things that we have done today? We learned how to prove the two theorems RHS and ASA, and I also kind of gave you guys a revolutionary switch or flip to that those theorems, saying that it is much more generic in nature. It doesn't have to be side between the angles. It can be any two angles in the side. Okay. Similarly for RHS also, though the theorem says hypotenuse on one of the side, I'm saying that any two side is fine. Any two sides. Yeah. And the way the reason why I'm saying so, because that is where we can relate the Pythagorean theorem and this theorem to come together. Alright? Now let's do one sum before we disperse. And the sum that we'll do will be only for doing a practice of what we have learned. And then when I give you guys assignment, I don't expect you guys to you want to sit down in the class. If you sleep, that will be a problem. Okay, so when I give you guys assignment, I don't expect you guys to send the assignment to me. Rather, I want you to do the assignment, show it to your parents and explain them that these are the questions I had, this is how I am solving it. It is not to make your parents happy. It is something that will tell you that, oh, Sherry, I did not ask the tables. Yeah, Sherry? So yeah, because I was not able to see Sherry on the screen. That's why I missed it. Sorry about that. So okay, let's quickly check with Sherry also. So 12 9 ja, 8 7 ja, 9 9 ja, 12 7 ja, 8 9 ja. Okay, so this is what Sherry gets. Good job, brother. So I think we everybody did, and if somebody did not do it, I would say we'll do that in the next coming class anyways, right? So make sure that you guys are spending 2 minutes every day. And now coming back to the assignment, right? So I see many of you are sending assignments to me, which is good. That shows that you are disciplined. You are doing that in a disciplined way. But what I expect you to do actually is do the sum and show it to your parents. Say, okay, fine. These are the assignments I had. This is how I'm solving it. Trust me, when you explain that to somebody, then you become from a student to a teacher. And teacher doesn't forget things. Okay? So That is why I ask all my kids to do the homework and show it to their parents. And parents should confirm me that yes, I have checked the assignment. That way, they will get the confidence that yes, you are learning the things right way. When you explain to them, you would also know that what you know, you are able to talk through it. Because if you are able to do so, that means the concept has gone deep inside. If you get stuck, that is when your parents will reach out to me and say, sir, my child did not understand this concept, or he or she was not able to explain it to me. That is when I will get that clue that yes, I have to explain something one more time. In a better way, in a different way, in a simpler way. Yeah? So that is the purpose. So remember, don't send the assignment to me. If you don't send to me, you are perfectly fine. But make sure you are never ever forgetting to show your assignment to your parents. There could be a week when you do the assignment, your parents are not able to see it. That is when you can send it to me, say, sir, this week my parents could not check. Can you check my assignment? Okay? And when you are showing the assignment, just don't show the assignment, explain. Say, okay, let me explain you what I have done. If you are able to do that, you are going to a next level of learning, okay? I have never seen anybody learning something and then being able to explain it. The day you are able to explain, you are a different student altogether, okay? Yeah? Let's do it. So, let's do one sum. And this sum is not a difficult one. It is just going to be something that we have learned. And we'll try relating that with the knowledge that we have got in the class today. Let's say I have these two triangles. This is 5, this is 8, 5 centimeter, 8 centimeter, 40 degrees, 40 degrees, and 8 centimeter. So I have two triangles. Triangle, this one has one side is 5 centimeter, other side is 6 and 8 centimeter, and the angles are 40 and 70. Here I have other triangle which has side is 40 and 7, angles are 40 and 70 degrees. One side is 8 centimeter, this side is 14 centimeter. I want you guys to find out the length of this side, this angle, and this side. Again repeating the question. This triangle has three sides. This side is 5 centimeter, this is 8 centimeter, and the angles is 40 and 70. This triangle has 40 and 70 as angles. This is 8 centimeter, this is 14 centimeter. Sorry, 12 centimeter. And then I want you guys to find out this side, this angle, and this angle. Yeah, Vivan, you raise your hand. Tell me. So this angle is 1. Tell me what is 1. This side is 2. Tell me what is this. This side is 3. Tell me this. This angle is 4. Tell me this. So I want, yeah. What is 1?
The angle is, it is 70.
Okay.
And for number,
Okay.
it is,
What is this one?
I cannot,
Number 2.
I can't see the whole proper.
So okay, this is 5, this is 8, this is 40, 40, 40, 70. You found this as 70 degrees. This is the second triangle where this is 40, 70, this is 8, and this is 12 centimeter. So I want you guys to tell me what is this 2 and what is 3.
The 2 is 12.
2 is 12 centimeter. Okay. How about 3?
And number 3 centimeter.
5 centimeter. Okay.
And
4.
the number is 17.
Okay. So how about you, Cherry? What was the answer?
I have the same.
Same answer. How about you, Pranav?
So I got the same.
Okay. How about you, Sanvi?
I got the
Same. And everybody used probably one thing was sum of all the angles for a triangle, and then you used ASA and SAS theorems, right? To find the matching this thing. You prove them congruent and then use that. Okay. Now there is a problem with the question. Okay. So Amoga, what was your answer? All the same? Okay. Now this question has had a problem. Your answers were correct, but the question was not right. Yeah, tell me, Vivan.
You can't make a triangle with 5, 8, and 10.
5 plus 8. No, you can. You can. 5 plus 8, 13. This is greater than 12. As long as some of the two sides is greater than the third side, you are fine. Now look at this one. 12 plus 8, 20, greater than 5. That is also fine. 12 plus 5, 17, greater than 8. You are good. That one is fine. So what that says is, sum of any two sides, A plus B, has to be greater than third side. So that is fine here. There is another problem. Can anybody guess? Okay. So I have not explained that to you guys. So what in any triangle, the sides are in the proportion of the angle. Bigger the angle, bigger the side. Smaller the angle, smaller the side. Meaning if this angle is big, the side opposite to this will be big. If this angle is small, the side opposite to that will be small, right? Because it will be squeezing the other two sides closer, right? If this angle is small, meaning this is moving here, this side will be smaller, right? So here you should see, you got these two angles at 70 degrees. But the side, one side is 5, one side is 8. If the angles are same, the sides opposite to that will be same. Okay? So this is actually an isosceles triangle where the two angles are matching. The two angles are same, 70 and 70, side opposite to that and side opposite to this will be the same. Yeah? Does it make sense? Okay. Okay. So again, whatever problem was given, you guys solved it right. There was nothing wrong with that. But when I looked at the answers, I realized that I had given you a question which had a problem. And that problem, people would probably not care if you are not being very, vigilant about the information. Okay. That's why when you look at the properties, now you guys will probably appreciate why I was wasting so much time walking you guys through the property of each and every shape. Because that is very important. You will never be able to draw a triangle. If you ever try drawing a triangle with side as 5 centimeter, 8 centimeter and 12 centimeter with this kind of angle, you cannot draw it. You will not be able to draw it because this is defying the basic principles of geometry. Okay? Alright. Thank you so much for your time and enjoy the rest of your weekend. Have fun. We'll talk again on next Saturday. And as I said, assignments, you will not send it to me. You will show it to your parents and you will try explaining to them. Okay? So wait for the